Hi guys, so today we'll be solving this problem called super palindromes. Let's solve it. Let's say a positive integer is a super palindrome. If it is a palindrome, it is also the square of a palindrome. Given two positive integers left and right, represented as strings, return the number of super palindromes integers in the inclusive range left or right. So we've been given a range of strings. So for example, left is equal to 4 and right is equal to 1000, and both of them are strings. And we need to identify how many number of palindromes are possible between them who have their squares also a palindrome. So for example, 4 uh, is a palindrome because it is a square of 2, and 2 itself is a palindrome. 9 is a palindrome because it is a square of 3, and 3 itself is a palindrome. 1 to 1 is also a palindrome because 11 is a palindrome. So 11 square is 1 to 1. 484 is also a palindrome because maybe 484 might be you know a square of some number which is also a palindrome. So we need to identify how many numbers are possible between those range, and which are a palindrome, and as well as their square is also a palindrome. So how we can solve this problem is very simple. We need to identify number of palindromes which are possible between the range, and we need to check if they are a palindrome. All right, so let's code it. So first we need to make a vector. So vector of long because we'll be storing a very uh, long more than integer max value numbers. So 1 2 3 4 5 6 7 8 and 9, all of them are palindrome. All the one digits are palindrome because obviously they are same from both the sides. So we'll be putting all the palindromes in this vector called v. Then I'll run a for loop. Int I is equal to 1, I is less than equal to, we can do long underscore max, but we don't need to do that because every palindrome will be between 1 and 8000. Obviously the 8000 that we are taking here will be two strings. Okay, we'll be reversing the first half, first half, and then we'll be adding it from the end. So we'll be considering that, and the number that we'll get, so say suppose 7999 and 7999, so both of them is the maximum palindrome that we can get between 1 to 8, 1 to whatever number that we want, 1 to int underscore max, or maximum number that we can have an integer. So only 7999 and 7999, that is the last palindrome that we can have. So that's why we are considering 8000 here. So we do that, we run a loop from 1 to 8000, then we make a string, let's say L, which will be taken from I. Then I'll be making another string R, which I'll be initializing it to L, and then I will reverse the string R. Okay. Now, as we do this, we put the number. So we'll be converting it to long, STOLL, and concatenating the left as well as the right, which is left is the normal string, normal number maybe, and right is the reverse of that number. So adding that will give us a palindrome, obviously. Then I run one more loop. So let's call it D, which is digits. So D is less than equal to less than 10, D plus plus, and we'll be pushing all the odd palindromes which are possible for that number. So L plus 2 underscore 2 underscore string plus R will be put in the vector that we have. Now, since we have generated all the palindromes which are possible between 1 and maximum value of integer, now we check how many palindromes are possible which satisfy our conditions. So for that, char c in auto c in v. Now we make one long. Let's name it c1 is equal to c into c. Now let's run a for loop. No, wait. Let's call a function called isPalindrome to check. And before that, we need to check if it is in the range as well. So stoll c1, uh, whatever left or right. So if it is in between left and c1 is less than equal to stoll right. Okay. And then one more function that is palindrome will give us if that number is palindrome also. So yeah, if it is a palindrome, so that function would be checking there, and simply if it satisfies all these conditions, we increase the answer, and then we return answer here. Now let's just write the is palindrome function. We are done with the code now. Uh, so is palindrome will simply return a bool value is palindrome string c1. Okay, we need to pass string also. So since this is a long, we need to pass string here to 2 underscore string c1. Okay, so here we check int I is equal to 0. So we do it by 2 pointer. Int I is equal to 0, j is equal to c1 dot size minus 1, while I is less than j. We do check if c1 of I is not equal to c1 of j. Then we break the loop. Break. We'll return false here. Okay. So we know that that is not a palindrome because the strings don't match, the characters don't match. Otherwise, we do I plus plus and j minus minus. And after this loop, we return true. Okay. So what we did first is that we generated the strings and the number of palindromes which are possible between 1 and 8,000. Then we pushed into the vector of number of palindromes which are between that range. And we also put a condition for odd palindromes, which is if in between we have any number, so that makes it an odd palindrome. Then we simply check if it satisfies all the conditions, that is if it is between the range and if the number is also a string. So we increase the counter, which is answer, and we return answer simply. Let's run the code to see if there's any bug. Okay, there are 2 underscore string d. Okay. Hmm. Okay, we have a wrong answer here. Expected 2. Mm-hmm. Okay, d can be 0 as well, right? So let's run on this test case. Yeah. Okay, that is accepted. So I hope you guys understood the problem today and do solve it. It's a tricky one and it's a hard one, but this is a very smart way to do it. So do solve it. Thank you.